This video talks about the change of order of integration and evaluation of the double integral, integral from 0 to 1, integral from y to 2 minus y, function is xy, dx dy. The four steps involved in the change of order of integration and evaluation problem is: step number 1, check for the limits. If the direction are going to be correct, then you leave it as such. If the direction is going to be different, then you will have to rewrite your problem. Number 2, sketch the region after identifying your region of integration. So the sketch will help you to move to your step number 3, where you fix the new limits. So once the new limits are fixed, step 4 is the final one, where you evaluate the integral using your new limit. Now to go for our first step, we check the limits direction. Now you have the limit to be y and 2 minus y. Y cannot be the limit of itself, so you know that this has to be the limit of the variable x. So y cannot be the limit of y, so you have x to vary between y to 2 minus y, in which case dx will be integrated first and then followed by it y, the constant limit from 0 to 1, will be integrated next. So as such, the given problem is in the right order and doesn't require any change. The second one is to identify the region and sketch it. So the limits for us are given as x equal to y, x equal to 2 minus y, y equal to 0 and y equal to 1. Always keep in mind, use two colors to sketch the region so that there is no confusion when to identify the axis and the region which has to be evaluated for. So we will have the axis to be given as x and this as your y. Now going for the plotting of the graph, y equal to 0. Y equal to 0 is our x-axis. So we will first plot it. So the x-axis, we plot it in the colored region. So this is a part of our boundary. So this gives me y equal to 0, the required part. Next, y equal to 1. What will be y equal to 1? Y equal to 1 is a line which is going to be just parallel to this line called as y equal to 0. So when we have it, we can draw it over here. So this is my line called as y equal to 1. So next, going for the line x equal to y. What is x equal to y? So we will try plotting the line x equal to y. Substitute the points over here. So when x will be, y takes the value 0, you substitute y as 0, then you have x as 0. So it is 0, 0. So when y takes the value 1, x also takes the value 1. So this x equal to y is a line that passes through the point 0, 0 and 1, 1. So this is the point 0, 0. Say this is going to be 1 unit. So this is going to be the point 1, 1. So we have the line which passes through 0, 0 and 1, 1. Next, about the line x equal to 2 minus y, or you have x plus y equal to 2. Now again, give y to be equal to 0. When I have y as 0, then I have my x to be equal to 2. When I have this y to be equal to, this x to be equal to 0, when x is taken as 0, then we have y as 2. So taking these 2 points, 2, 0 and 0, 2. So this line x plus y equal to 2 passes through the point 2, 0 and 0, 2. Now when we consider this perpendicular, it will cross the x-axis at the point. So this is going to be 1, 0. So at an equal distance, we will try to plot the point 2, 0. So this is the point 2, 0. Similarly, this is the point 0, 1. So this is going to be 0, 1. One more unit, we will take this as 0, 2. So our axis is going to be, the line is going to be something that passes through this and reaches it. Okay. So now we have got, the next thing is to identify the region. Now check which is the closed and bounded point. We will see whether this is going to be closed. Now when we have it, we can see that this is an open space, this is an open space, this is an open space, and now coming over here, this line is what you introduced, so this is an open space. This line is what we introduced for imagination of axis, so this is open space. And so now we are clear which is going to be our closed region. So the closed region enclosing this is going to be this part which is available over here. So step 2, we have fixed the limits, we have identified the region and we have sketched the region. So we have the lower base triangle to be the one in which our integration has to take place. Now moving to step number 3, fixing the limits. How to fix the limits? Now we have the given problem. Given problem is in which direction? Is in x direction. Is in x direction. So when we change it to the direction of y. So now we are going to draw a line parallel to our y-axis. So what is the direction of y? Y moves from bottom to top. Y moves from bottom to top. Now we can see that as we move from over here bottom to top, this is how the region gets evaluated. The region is not uniform throughout, but it changes its direction from the line x equal to y, from this part to the line x plus y equal to 2 over here in this region. Hence, the evaluation cannot be done as one single integral, but this has to be done as a part of two integral. And how about that? Now, try to split this into two parts over here. One for which the variation in y direction is from y equal to 0 to y equal to x. And the second one over here in this direction where you vary from y equal to 0 to y equal to 2 minus x. So we will make this into separate part so that we will be able to easily fix the limits. So we have a triangle like structure which can be now divided into two parts with the equation of the lines being, so this is going to be my line y equal to 0. This is my line x equal to y, and this is my line x plus y equal to 2. This point of intersection is 1, 1. This point of intersection is 2, 0, and this point is 0, 0. Now when I am going to draw a strip parallel to my x-axis in the first region, so this is my first region. So what happens over here? I start from over here and I move over here. So let me name this as the region 1 I1 and let this be named as region 2 I2. So the total integral I is nothing but the addition of I1 and I2. So now let's fix the limits for our I1. So where does our I1 vary? Okay, so now for the change limit or new limits in terms of y. Y begins its journey here and moves to the top. So y varies from 0 to, and at the top y is equal to x. So 0 to x, and the second limit. Now this point is going to be a drop from the perpendicular of top over here. X is 1. So this is the point 1, 0. Now notice the changes which happen in the direction of x. So the first coordinate is 0, the first coordinate is 1. So where does our x vary? My x varies between 0 to 1. So this is my new limit for my integral component number 1. And now let me go for my integral component number 2. In the direction of y in your region I2. So how to fix about it? Draw a line parallel to your y-axis. Now you get your limits fixed from top, bottom to top as we move. The bottom line is called as y equal to 0, and the top point is called as x plus y equal to 2. So y will be equal to 2 minus x. So this gives you 2 minus x, and next comes the limit of your x. Where does our x vary? X now begins with 1 and it ends with 2. So the limit of x is from 1 to 2. The function to be evaluated is xy. So dy first and then followed by it dx after we change the limit. Xy dy first and then followed by it dx. Now let us evaluate this. X is a constant temporarily when you integrate it with respect to y. Y on integration is y square by 2 between the limits 0 to x. Still to be integrated 0 to 1, x by 2 is a constant. Applying upper limit for your y, it gives you x square minus 0. Now integrating with respect to y, x cube on integration gives you x to the power of 4 by 4. Already a 2 is here, so 0 to 1. So this gives me the answer as 1 by 8. So the value of my integral number 1 is 1 by 8. So now let's move on to the second integral. X is kept as such. Y on integration is y square by 2 between the limits 0 to x, 2 minus x, and still we have 1 to 2 to be integrated. Now applying the upper limit, x by 2 into 2 minus x the whole square dx. So this has to be integrated between the limit 1 to 2. Now expanding it using a minus b the whole square formula, we have it to be equal to 4 plus x square minus 2x. So 4x. So this has to be integrated between 1 to 2. We move on to the next line to evaluate x by 2 into what is going to be is 4 plus x square minus 4x. So this on expansion between the limits 0 to 1 dx. We have 4x 1 by 2, let us take it constant, my plus x cube minus 4x square dx. So let us integrate it between the limits 0 to 1. So 4 x square by 2 plus x cube x power 4 by 4 minus 4 x cube by 3. And you have 1 by 2 outside between the limits 0 to 1. So this can be cancelled off with 2. The limit of integration is from 1 minute. The limit of integration is from 1 to 2. So because we are in the second part of the integration. So the limit of integration is from 1 to 2 because we have the limit to vary between 1 to 2 in my region I2. So the limit is from 1 to 2. So changing the limit and applying it between 1 to 2, we have 1 by 2, 2 into, applying the upper limit 2 square is 4 minus 1 square is 1 plus 1 by 4 times of 2 power 4, 16 minus 1 power 4 is 1 minus 4 by 3 times of 2 cube is 8 minus 1 cube is 1. So we have this as 1 by 2, 2 into 4 minus 1 is going to be 3 plus 1 by 4 times of 15 minus 4 by 3 times of 7. So we take the LCM, 4 3s are 12 is going to be our LCM. So on simplification, we have this to be equal to 5 by 24. So this is my value for my I2. So what is the total value for I? It is I1 plus I2. So it is the previous line. We had the value of I1 to be equal to 1 by 8. So this is going to be 1 by 8 plus 5 by 24, which on simplification gives us 1 by 3. So this becomes the final answer.